Welcome to the day 3 out of 30 where we are learning the mind-blowing physics question that is equivalent to 100 of JEE and NEET questions. And if you're following our journey from the very first one, you might know we are pretty crazy about center of mass. Where in our last video we already got the idea of semicircular ring that is having the center of mass of 2r by pi, and we have to remember it. Cause this time we are having a semicircular disk, but this time in that semicircular disk we are just imagining a smaller part, a smaller stripe, which is a semicircular ring. So if you're looking for its own center of mass point, that is the radius twice with divide by pi. That's what we just found in our last video. So I told you have to remember that. And one more thing that you have to imagine, this stripe having a small length or small width of dr. Obviously, as we know, their mass should be del m, a smaller mass, and we need to find that one, right? So here we go. The total radius is r, therefore this is an area having pi r square by 2 and its mass is m. So what will be the unit area mass? That is m to pi r square. Just flip it out, right? And after that, what will be the part of mass for this part only? Before that, you need to understand what is its area. So just think about that. If it is a total stripe with a smaller length of dr, which is its breadth, then what will be its length? Its length will be pi smaller r only, cause we know that it's a semicircle, so the circumference will be its own length, right? So what should be its area right now? Come on, it's a rectangle, bro, so you just need to multiply that pi r with del r. That's it. So, and you need to find the mass of that part only, so pi r del r should be multiply with that thing just to get the unitary method, and pi gonna cancel each other, so the simplified form should be 2m small r by capital R square with a dr, and that is what you got as dm. Now that is center of mass formula, that is y of dm, which is divided by the total mass. I hope you all know that. So it will be ycm. Right now it should have the value of y, which is already pretty much clear to us. It is 2r by pi. And what should be the limit? That should be from 0 to r with the value of dm that is already we discovered at 2 pi r by r square with a dr. And the good news is that 4 by pi r square, that's gonna come out, and 0 to r square dr, that's remaining in that integration. So it's gonna be r cube by 3. So pretty much clear to us that 4r square into r cube by 3, which is lead us to 4/3 of r by pi, and that should be your solution.